Hello everyone. In this paper, we present a classification approach for textual file formats. In this research, we have considered three languages: Persian, English, and Chinese. Let's start with file type identification. The first step to analyze a file is to recognize its file format. It is a principal task in many applications, such as web content filtering, network monitoring, malware detection, and some related applications. Another important application is data forensics. File identification methods can be divided into three categories. Identification based on file suffix, based on magic bytes, and file identification based on contents or context. File suffix is the most basic method. It is possible to effortlessly change the file extension manually, so this method is not very effective. Magic bytes method can be described as a method which search for a predefined signature for the file that exists either in the beginning, that is to say header, or at the end of the file. In most cases, only a fragment of file is at hand, so there is no access to the header and footer. So it's not the best fit for the challenges that we mentioned before. Context or content-based methods are relatively newer, great results in similar researchers. In this method, some features are extracted and a machine is trained with these features. The main challenge in this method is to provide a data set that is acceptable, that provides an acceptable training. And so it is computationally more demanding than the two other methods. One of the main category of file types on internet is textual files. In this paper, we have considered these file types. Up to 2007, most approaches had no learning phase. They obtained a centroid optional, a model from BFD and ROC, and then they used a distance metric to determine the file format. For example, you can see some of the researchers that I'm not boring you with the details. To the best of our knowledge, no one has studied the effect of context language in classification of textual file fragments, the language of the file fragment. In this article, we have considered this problem for five types of common textual file formats: PDF, doc, docx, RTF, and TXT. By employing two different scenarios, we examine the effect of language on classification accuracy. First, we consider same languages for training and test, and then we consider different languages for training and test files. Key factors to be mentioned are that we have several users, so the fragments are not necessarily from a specific file. Different text files and file types are transmitted in our model. Files are segmented into several fragments, and the packets won't necessarily be in order of the same as the order in the file. For classification, a supervised machine learning method is applied on extracted statistical features that are extracted from fragments. One of the main challenges in supervised machine learning is to provide comprehensive data sets. This problem is investigated in this paper. Our files, the basic files of doc, docx, rtf, and txt are gathered from govdocs, English data sets. PDF files are manually created from doc files of the govdocs dataset. Files for 2 other languages of Persian and Chinese are gathered from the internet. These files have no picture in them, so it's a simplification we have considered in the paper. The length of the fragments are considered to be equal to 1024. We designed a simulation so the header and footer have been deleted from files, and then from each of the files, 5 fragments are randomly chosen. This dataset has 1500 fragments for each language and each file type, so the dataset contains a total of 4500 file fragments. The dataset, as we mentioned before, is consisting of 15 different pairs of language and file formats. For feature extraction, we have used Fragments Expert. This is an open source software designed exclusively for the task of file fragment classification. This software is developed in our lab. The decision tree is chosen for classification. The reason to use decision tree is that we can visualize their decision steps and the results can be explainable. Of course, there are better machine learning methods with more accuracy. When the language of training, validation, and tests are the same, for example, in here, Persian, the decision tree is shown. As you can see, skewness is the most important feature. The results are around 85% in test, so we can assume that's a good result when the training and test languages are the same. When we use the same scenario for English language, you can see the results here. Entropy is the most important feature, and the average result is around 76%. For Chinese, we have medium ASCII code as the most important feature, and the average accuracy is around 86%. In the second scenario, different languages for training and test are considered. For example, when we train a machine with Persian language, the result for testing with English and Chinese are respectively around 58 and 62%. That are very lower compared when we use the same languages. This result indicates the importance of a comprehensive data set for training, and so we have good test results. The same results are obtained with English language, training with English language, and training with Chinese language. Interestingly, when we use a machine which is learned with Chinese language. The test with Persian language is promising and good. It's around 83%. That's an interesting result. To summarize the results, we consider two scenarios in this paper based on decision tree for classification of textual file formats. In the first scenario, training and test languages are the same, so as we expect, the results are good. But when the training and test languages are different, the results are not very promising. This is a point that is not considered in previous papers. We propose to investigate this problem in a bigger scenario with more file types. We think that the context of the files, especially textual file formats, is an important aspect that should be considered. Other than that, an effective feature set is proposed in this paper for classification of textual file formats. However, the distinction between PDF and docx is not very promising, and it does require more work to have a better classification between these two files. The main results, again, from this paper is that when the training and validation set are not same as the test set, with same we mean context. Their accuracy results are significantly reduced. That should be investigated in future works. Thank you for your time and consideration. Have a good day.